Now, to look for p-values in my chi-squared table, it's important to realize that the chi-squared doesn't care what our alternative hypothesis is. It doesn't care if it's less than or greater than or not equal to. The chi-squared table is always going to give us a cumulative probability, specifically as shaded up here. This right here is my p-value. So I don't need to worry about my alternative hypothesis. What I do need to worry about is my degrees of freedom. And when I go to find my degrees of freedom, it depends on what kind of test I'm doing. If I'm doing a goodness of fit test, it'll be the number of categories minus 1. So for instance, if I'm trying to see are people equally likely to be born in any given month, the number of categories would be the number of months, which would be 12. So degrees of freedom would be 12 minus 1 or 11. If I'm doing a test for independence, it's a little bit different. The test for independence relies on a contingency table, and so I take r minus 1 times c minus 1, where r is the number of rows and c is the number of columns, not including the totals. Once I've gotten my degrees of freedom, then I'm ready to go ahead and use the chi-squared table. Once I have my chi-squared value, the first thing I do is I find the corresponding row to trace across. If the row isn't there, just like on a t-table, we will always round down. That is, if I have degrees of freedom, let's say 29, and 29 is not on the chi-square table, I'd round down to 25 or 20, whatever's below that. So if necessary, I'll always round down. The other thing I need to do is when I go to find my chi-squared value, there's a good chance it's not on the table. If it's not on the table, that is, if chi-squared itself isn't on there, then what I do is I border it in between two values. So at this point, it's time to go ahead and do an example. I've got all this information. For our first example here, let's go ahead and say I have a chi-squared value of 1.97, and my degrees of freedom in this particular example is going to be 1. To find my p-value then, what I'm going to do is start off by looking at what row I have. I have degrees of freedom 1, so I'll be using this top row. The next thing I do is I try and border my chi-squared value in between values close to it. So although 1.97 isn't on there, I do see a 1.64 and a 2.07. That is, my chi-squared value, 1.97, would be in between those. If my chi-squared value is in between those, that means my p-value is going to be in between these two probabilities. So tracing them up to the top, I get 0.20 and 0.15, and what this tells me is that my p-value, once again, is right in between those. Now, something to notice is that as I trace those n probabilities across the top of my table here, they're getting smaller and smaller and smaller. That is, 0.25 is less than 0.2, which is less than 0.15, and so forth. And that's because my chi-squared values in the table are getting bigger and bigger. So while one chi-squared value might be here towards the middle, as I move out, the n tails there are getting smaller and smaller and smaller. So as the chi-squared values in the table get bigger, the n tails at the top get smaller and smaller and smaller. That's important because it tells me that down here, 0.2 is greater than my p-value, which is greater than 0.15, because I'm moving across the top of the table there. Now to go ahead and refresh what we just did, to begin with, I found my degrees of freedom. I highlighted that row. I found two values that were on either side of my actual chi-squared and traced them to the top. Because my chi-squared was in between those two, my p-value is in between those two n tails. This gives me a bordered region for my p-value, which will allow me to compare my p-value to 0.05.